Hi students, in this video we are going to discuss about position time graph for an object moving with positive velocity, negative velocity and zero velocity and rest. Now today our concept is position time graphs for an object moving with positive velocity comma negative velocity comma zero velocity and rest. And rest. Now, today our concept is position time graphs for an object moving with positive velocity, negative velocity, zero velocity and rest. Now, the first side heading. Position time graph position time graph for an object moving with positive velocity. Once again, position time graph for an object moving with positive velocity. Now take x-axis, take y-axis. On y-axis we take position or displacement. It is measured in meters. This is horizon. On x-axis we took time, that is in seconds along x-axis. In this case the graph is a straight line in between time as well as the position. This indicates position time graph for an object moving with positive velocity. Now Go for point number 2. Point number 2. Position time graph for an object moving with negative velocity. Now take x-axis, take y-axis. On x-axis we took displacement or position, that is the unit is meter. Now this is origin O. On x-axis we took time t, the unit is s. In this case the graph is like this. So this indicates that whenever time is increasing, the position is decreasing. The position time graph for an object moving with negative velocity, this indicates negative velocity. Okay? Position time graph for an object is at rest. Once again, position time graph for an object is at rest. This is point 3. Now take x-axis, take y-axis. Now this is x. Here position we measured in meters. This is origin O. On x-axis we took time t. The unit is seconds. In this case, now we draw a straight line which is parallel to x-axis. Means that the object is at rest or the object is zero velocity. That means whenever the displacement or position which is parallel to x-axis, in that case the object is at rest or zero velocity. Now we are going to discuss about average speed. Average speed. The average speed is defined as it is defined as the total path length traveled. The total path length traveled divided by the total time interval during which the motion during which the motion has taken place. Therefore, the average speed is equal to total path length whole by total time interval. Total time interval. Now, the SI unit is meter per second. Once again, I am repeating the concept. It is defined as the total path length travelled divided by the total time interval during which the motion has taken place is called average speed. Therefore, the average speed is called total path length by total time interval. Therefore, the SI unit of average speed is meter per second. Now, another one important point, that is it does not tell us in what direction in what direction an object is moving. Once again, it does not. That means the average speed does not tells us in what direction an object is moving. It is always positive. That means the average speed. It is always positive. Once again, it is always positive. Next point. If the motion of an object is along a straight line and in the same direction the magnitude of displacement is equal to total path length. Once again I am repeating the point. If the motion of an object is along a straight line and in the same direction, the magnitude of displacement is equal to total path length. Next, the magnitude of average velocity is equal to the average speed. Once again I am repeating the point. The magnitude of average velocity is equal to the average speed. Now go for one numerical. A car is moving along a straight line. Once again, a car is moving along a straight line. OP. It moves from O to P. It moves from O to P. Is 18 seconds and returns from P to Q. In 6.0 seconds. What are the average velocity and what are the average velocity and average speed of the car in going point A from O to P, question mark. Point B from O to P and back to Q. Once again I am repeating the question and see the diagram. Take a straight line. Here it is R minus 120 minus 80 minus 40 0 40 80 120 160 200 240 280 320 360. Consider it is point R and it is O and 240 is Q. It is Q. It is point P. Now here from O to Q is 18 seconds. Here O to P is 18 seconds and P to Q is 6 seconds. This is the question given by examiner. Once again I am repeating the question, my dear students. A car is moving along a straight line OP. It moves from O to P is 18 seconds. O to P is 18 seconds and return from P to Q. It took 6 seconds. What are the average velocity and average speed of the car in going from O to P and from O to P and back from P to Q? This is the question. Now solution. Average velocity is equal to displacement by time interval. Displacement by time interval, that is equal to 360 meters whole by 18 seconds, that is equal to 20 meters per second. Now average speed is equal to path length length whole by time interval. Average speed is called path length by time interval. That is called 360 meters by 18 seconds. That is called 20 meters per second. In this case, average velocity is equal to average speed. Once again, in this case, the average velocity is equal to average speed. This is part A, question number A. Answer. Now we are going to discuss B. Now, point B. Average velocity is equal to displacement by time interval. Displacement by time interval, that is equal to 360 minus 120 whole by 18 plus 6, that is equal to 240 whole by 18 plus 6, that is equal to 10 meter per second. Because 18 plus 6 is equal to 24, 240 by 24 gives 10. Direct step I wrote here. Next, average speed is equal to path length whole by time interval. That is equal to OP plus PQ whole by delta T. That is equal to 360 plus 120 whole by 24. That is equal to 20 meter per second. Now, point. In this case, the average speed is not equal to not equal to the magnitude of the average velocity. The average once again I am repeating the point. In this case, the average speed is not equal to the magnitude of the average velocity. Next, path length. Path length. What is path length? Distance. Path length we also called as distance. Distance greater than the magnitude of displacement. Magnitude of displacement. Next point. This shows that speed is greater than magnitude of velocity. Once again I am repeating. This shows that speed is greater than magnitude of velocity. Next point. If the car from O to P and comes back to O in the same time, in the same interval, therefore average speed is 20 meter per second, but the average velocity is 0. This is important. Once again I am repeating this point, my dear students. If the car from O to P and comes back to O in this same interval, in this case the average speed is 20 meter per second, but the average velocity is 0. Okay, so this is about the average speed, and when these two are equal, when these two are not equal, I just taught a numerical for you to make you understand. Okay, So, however, thank you very much for watching this video. So, thank you very much for watching this video. Thank you.